So it's become kind of a kind of a tradition to have someone from Double Fine come here and share their experiences with us. And of course, we want to keep that tradition alive this year as well. So our next speaker, he was the lead programmer of Broken Age, Full Throttle Remastered, Day of the Tentacle Remastered, and has been making major contributions to other Double Fine games as well. Please welcome Oliver Franzke to the stage.
All right, hi guys. Thank you for joining me this morning. Thank you for the kind introduction, and thanks Ralph for the very inspiring talk. In fact, in many ways, this talk will kind of stand on Ralph's shoulders, like he said. And it's going to continue in surprisingly many ways as a kind of a narrative, although it's totally unplanned. Because I'm also going to talk about something that doesn't work. Okay, sorry, tech. You know, there's a tech, it never works when you want it to work. All right, I'm just going to do this manually. That works. I'm going to talk about some old school games, mainly about these two, Monkey Island and Grim Fandango. Now, if you think about these games, you may have some associations. If you're like me, maybe you're going to think about the main characters in these games, Guybrush Threepwood and Manny Calavera. And these are, fabulous, awesome characters. Maybe you think about all the conversations you had with non-player characters, Monkey Island with the important-looking pirates, or in Grim Fandango with Gladys. Or maybe you think about the worlds that these games created and the stories they told. Or maybe you think about some of the puzzles that you just couldn't figure out, and eventually you did. And there was a time when I was younger where there was no internet, and if you didn't have a magazine that told you how to get past some puzzles, you really were stuck. Of course, these days you're just way too tempted to just look it up and move on. Now these are all completely valid points. These are adventure games after all, and these are kind of the typical things you would associate with an adventure game. What I want to talk today, or what I want to talk about today, is something completely different, and that's the technology behind these games. And I hope that after this talk, I can convince you that these games left a legacy, not just because of the characters and the stories and the game design and the puzzles, but also because of the technology. Because in many ways, not only did they innovate, they actually revolutionized the games industry. And like Ralph said, we're still building on top of the kind of legacy that was set back then. Now, before we're going to start, I just want to say a few words about myself. Like I said, my name is Oliver Franzke, and I started in the games industry in the year 2000 in a small German games studio. Eventually moved to London, worked for Sony there, doing the launch of the PlayStation 3, before moving to San Francisco in California to join LucasArts Games. There, I was part of the team that worked on the Monkey Island Special Editions. And then about 2010, I joined Double Fine Productions as a senior programmer, where I'm still working today, although the last 3 years I've been working remotely from Germany, where I'm raising my family. And if you look closely, you actually see a whole bunch of games. I was the lead programmer of Broken Age. You'll notice some other adventure games, Day of the Tentacle, Full Throttle, Monkey Island, Grim Fandango. And in a way, I really consider myself pretty lucky in this regard, because it's a genre that, I like a lot myself. I like playing these games. I like making these games. So in a way, kind of my job title looked a little bit like this the last couple of years. But instead of venturing into kind of old tombs to find treasures, or I guess the PC version to excavate artifacts, I actually go into old code bases to try to figure out how did they work, and to make them accessible again, not through emulation, but as of on actual concurrent current hardware, to make them available again for players who perhaps enjoyed them when they were younger, when they first came out, or for a whole new generation of players who perhaps never played these games. So sometimes I jokingly say my job title is code archaeologist. And of course, being a code archaeologist means I don't get a cool hat and I don't get a whip like Indy. But on the positive side, I also don't get chased by a gigantic stone ball. So there's that. Now, in today's talk, I'm going to talk about mostly these games, because these are the games that I have personal experience with. Now, if you see me later, maybe you'll see that I've actually got quite a fair amount of gray hair these days, especially since the birth of my daughter. It feels like it just kind of exploded. And I am old, but I'm not old enough to have worked on the original versions. In case you're wondering when these games were released, you can see that here. My contribution to these games and my connection to these games is through the special editions and the remastered versions. And for me, that experience was kind of magical, since I loved these games so much as a child. To be able to actually work on some of these games that were my favorite games as a child, and to bring them back was really a magical experience. Now, one way to look at these games is by the technology that was used to make these games, and in a way that's the focus of this talk, of course. And you would also, if you were to think that these are all adventure games made at LucasArts, they're probably all made with the same engine. And you would be mostly right if it wouldn't be for Grim Fandango. All of these kind of classic 2D adventure games made by LucasArts are made with an engine called Scumm. And then Scumm really revolutionized the games industry, and I'm going to come back to that in just 1 second. And then in the second half of the talk, I'm going to talk about the engine behind Grim Fandango, which was a completely different beast called Grime. And I'm going to talk about why it was even necessary to have a whole new tech base for that. But let's jump straight into Monkey Island. So, like I said, Monkey Island was made with an engine called Scumm. Now, Scumm is an abbreviation that stands for Script Creation Utility for Maniac Mansion. This was a game made in the mid to late 80s at Lucasfilm Games, so this was even before LucasArts existed, by now legendary game designer Ron Gilbert. And if rumors are true, the reason that we even have any of these games is because there was a rivalry going on between George Lucas and Steven Spielberg in the 70s about who can make the most successful movies. And when Steven Spielberg started to kind of venture into the entertainment industry, George felt he had to kind of follow suit, so he can't lose that competition. So he started a games division as part of his Lucasfilm company that he called Lucasfilm Games. And there he hired, I already mentioned Ron Gilbert, but also Chip Morningstar. We heard from Ralph, who worked at Habitat. In fact, Habitat was very important as a kind of foundational element for these games. So in a way, Habitat is kind of alive through these games in an indirect way. So Maniac Mansion, for many people, would consider this kind of like the first, big, very successful visual point-and-click adventure game. This technology that was made for this game was very powerful. But in the end of the day, like Ralph said, it doesn't really matter too much, kind of the tech and some other stuff. What really matters is kind of the games you make with something, right? Because that's, in the end of the day, that's going to hopefully last, and hopefully there will be, a Wikipedia entry or somewhere where some of these games will be listed. So here you can see all the 12 games made at LucasArts over a period of about 10 years. Many people consider this or call this the golden era of LucasArts. I personally love all these games. I played them all, and to this day I come back every once in a while to play them again, and I'm already looking forward when my daughter's old enough to play some of those with my daughter. I'm actually curious, who here in the audience has played at least one of these games? Yeah, awesome. All right, wait. Who in the audience played at least 2 of these games? Nice. All right, last question. Who here in the audience has played every single one of these games? Yes, Ralph, thank you. There's some other people too. Awesome. Now, what many people don't know is that Scumm, the engine that powered all these games, was actually also used outside of LucasArts. Because when Ron Gilbert left in 1994 to start his own company, Humongous Entertainment, he came to an agreement with LucasArts that he could continue to use this technology for his own purposes. And Humongous really kind of focused on educational adventure games for kids. And he actually, Humongous ended up making about 40 or so games with Scumm as part of the Put franchise, Pajama Sam's. Depending on how old you are, you may actually have played some of these games. Now, what is really amazing is, if you think about historically speaking, Scumm was actually used to make about 50 games. Now, it kind of sounds ridiculous today, but back then that was completely non-standard, completely crazy, completely revolutionary. Back then, when you made games, you didn't just like make an engine, reuse it for multiple games like you do today. Very often, you wrote a very bespoke piece of technology because you had to, in order to even run fast enough on the platform you want to be on. And not only that, you had to often implement the gameplay logic, obviously in the low-level programming language like C and assembly. But with Scumm, they went a completely different direction. The goal was to keep the engine power that kind of makes everything appear on screen and makes sounds and handles input, all of the stuff, to keep it the same between these games, and that you could just, in fact, just replace the data, and then you would, have a new game. And of course, these days, it's completely common. Everybody uses, or most people use Unity on Unreal. You wouldn't even think about writing your own engine from scratch because you would probably lose that battle. Now, how did this work? One of the core decisions that actually made this possible is to move all of the gameplay logic out of the low-level layer, that is the engine layer, into a high-level domain-specific language that was called Scumm. Now, these days, you would call this scripting. So you can say that Scumm kind of popularized scripting in the games industry. Now, again, today, it sounds like, yeah, what's the big deal? Everybody, you wouldn't even think about making a game without any kind of scripting, especially for the gameplay bits. But back then, this was not common. And so, of course, the benefits of scripting back then were what they are today, that it's much faster to write gameplay scripts. And back then, in the mid to late 80s, compiling your game, the C aspects or the low-level aspects took much longer than it does today. So the fact that you could just write a little bit of gameplay script, you didn't need to compile it, it would just kind of run, allowed the game designers like Ron to just iterate on these ideas much, much quicker, and to experiment with different ideas and kind of see what works, what doesn't work, and kind of find the fun this way. I kind of don't really, this phrase, find the fun, I still find it a bit weird, but in a way that really represents this in the best way. And now, of course, you still have to run the script on a specific piece of hardware, and this is where SPUDIM comes in. Now, SPUDIM stands for Scumm Presentation Utility TM. And there's a little side note here. All of the names of the executables in this kind of LucasArts Scumm ecosystem all have really funny names. There's a tool called Phlegm and one called Bile. And I think that proves the point that you should probably never let your programmer decide what a program should be called, because he's going to come up with really funky names. And I'm totally guilty of that myself. So SPUDIM, is in many ways what you would these days consider kind of just an engine framework. So, like I said, it handles display to make things appear on screen, and sound. It handles input, handles memory management, and back then you had to think about diskettes, and you don't have all the data necessarily. You had to handle floppies, putting in floppies and taking them out and whatnot. And so the way this works is these scripts up here, they were all, and I'm going to show you a little bit how they looked like in a second, were converted to a more efficient representation. These days you would call this bytecode or a compiled version. And then so the SPUDIM layer would interpret that script. Now, SPUDIM was also incredibly portable, not only because all the gameplay was in kind of this high-level domain-specific language, but SPUDIM also had a very smart design decision that was made early on, and that is, even though often you needed a very low-level representation of all the functionality in there to run fast enough on, let's say, a C64, Eric Wilmunder, one of the main programmers of the Scumm engine, made a decision early on that every single function in SPUDIM had to have a C representation. And that meant if you wanted to bring your game to another platform, all you need to do is take all the C source code, compile it for the new platform, and it would run. Wouldn't run well, but at least you had a starting point. You could kind of figure out what needs to be optimized. And this also hugely helped us with the remastered versions. Now, as far as I know, the Scumm script for any of the LucasArts game was never really officially released, which is why I'm very glad that Ron Gilbert himself had some of the script for Maniac Mansion in a GDC talk he gave a couple of years ago, the classic game postmortem about Maniac Mansion. You can see the link down here. It's free on the GDC Vault. So if you enjoy this talk or have any interest in these kind of games, I highly encourage you to check out this talk. If you know Ron, you'll know that this is a very humorous talk, but also very informative. Now, in this specific example, what we're going to do is we're going to look at the grandfather clock in the entry hall of Maniac Mansion. And so don't worry, if you're not a programmer and you don't want to even don't care about reading code, there will be just a few slides with this, and then we're going to be over it, and I'm going to try to be extremely high level. Now in this script, what we're going to do, first we're going to give it a name up here, clock tick. And then there's a statement with the do and the curly brackets, which essentially just defines an infinite loop. So all the statements in this block get just executed over and over again until the script is canceled or stopped, and that usually happens when you leave the environment. Now, the first thing we're going to do is take clock state and say equal not clock state. Now, as a binary operation, that means we're negating the state. So if the clock pendulum is on the right side, we're going to move it to the left side. If it's on the left side, we move it to the right side. And then we need to update the visual representation of the clock. That's what we're going to do with the next statement. Object, living room clock, state, clock state. So really what that does, it just sets the sprite index. Then we're going to play a sound that goes along with that state change. And then we're going to wait for a second. And then we continue. And so I hope you agree that there's actually a very easy way to just kind of add this ambient animation and this little objects into the world. And you didn't need an animator for it. You didn't really, you could essentially just do it as a game designer. Just throw something like that in, even at a fairly late stage in the game. And let's look at a bit more complex example. Now here we're going to look at a cutscene. Now, the fact that the word cutscene exists today is also thanks to Scumm, because the main mentioned when you had like a pre-animated sequence, it literally cut away from the screen what the player was interacting with to a different part in the house, and you would see that scene, and then would cut back. So depending on whether or not you like that word cutscene, you can say thanks to Ron next time you see him, or not, I guess. Now, in this cutscene, what we're going to do is we're going to look at Nurse Edna to talk to Ed. And so the first thing we're going to do is we're going to put the nurse in the bedroom on the right side of the screen at 60/20. Now, back then, the resolution was much lower. These days, that's obviously a ridiculous resolution. So somewhere around here. Then we're going to tell the game, OK, now you should show this room with the nurse in it by using the camera follow command. Then we're going to say, OK, nurse, walk to the center of the room using the walk to command. And then we're waiting for this walk animation to finish. And then we're going to let the nurse say the line, what's your point, Ed? And then we wait for that to finish. Now, I still find this incredibly fascinating and such an efficient way to represent this actually fairly complex sequence in just 6 instructions that are kind of just in a linear sequence. In fact, when I first discovered ScummScript as part of the Monkey Island Special Editions, I was really taken aback by the fact how closely this resembles like a stage play. And I don't think that's by coincidence. Excuse me. If you ever seen a stage play, you kind of have stuff like this where actor enters stage on the right and walks to the center and says a line. So very much in a similar vein, this kind of script is represented. And as I said, this is a very domain-specific language for the purpose of adventure games. It wouldn't really work for a strategy game or a first-person shooter, but for the purpose of making adventure games, this is absolutely fantastic. And I kind of want to show you and prove to you that it really is a much more efficient version as a kind of code representation than what was common at the time. So let's just take a look at these 3 lines down here where we're waiting for the nurse to arrive at the center of the room. We're going to say the line, what's your point, Ed? And then we're going to wait for that also to finish. If you were to imagine implementing this in something like the representation that was common back then, this kind of C-like language, it could look something like that. Now, I should point out, this is a completely fictional code I made up for this talk. It doesn't exist in any of the Scumm gigs or anything. It's just purely there to kind of show you how this could look like. And even if you don't even read code, or you're not a programmer, I hope you agree that this is way more complex, right? There's way more lines, there's nesting, curly brackets, and who knows what else going on. And as a programmer, we know that with additional complexity, it's also much easier to add bugs to that code. And not only that, if there's a bug in that code, it's going to be much more complex or complicated to find the bug in this representation than in that representation. And furthermore, if you imagine you want to make any change to that script, let's say you want to make the nurse walk to the door first, then close the door, then return to the center of the room and say the line, what's your point, Ed? This would be like 2 or 3 lines in ScummScript. But in this representation over there would be a much bigger endeavor. Now, if you're curious and you want to learn more about the kind of language, the Scumm scripting language and kind of the commands and what they do, I encourage you to check out Eric Wilmunder's website. A couple of years ago, he started posting some of the internal documents from LucasArts. Thank you, Eric. On his website. The website has since then gone offline. I'm not surprised by that at all, since they're all internal documents. But thankfully, the web archive still has a snapshot. So You can check that out and grab it from there. And you may want to just get all these documents and save it on your computer before someone at Disney figures this out and takes it down there as well. Now, an interesting document is the Scumm tutorial. This was given to new recruits at LucasArts, so-called Scummlets, and it describes kind of how you make games. And I just kind of want to point out this like sub-tagline here. It's called "Rising to the Top of the Software Cesspool." I still find this hilarious, and I think it kind of reflects kind of the humor that people had back then, working on Scumm in these games. And you also find some of the design documents for Maniac Mansion and Monkey Island and Sam & Max and whatnot. So, excuse me, it's a real treasure trove for kind of the adventure game historians. Now, if this kind of isn't enough, that you had like a portable engine that was reusable across multiple games, that wasn't really the last innovation that Scumm brought. In fact, it brought another very revolutionary aspect as a kind of technology piece, and that is it introduced, excuse me, cooperative multitasking. Now, these days, you might know this as, on a different word, like coroutines or fibers. And what I mean by that is it allowed you to express behavior that happens in parallel in a very efficient way. So if you imagine you want to describe the pirate that's spinning in a chandelier, and you want to look at the fire that's animating in the fireplace, and maybe Spiffy is kind of looking around with the bone in his mouth. As a programmer, the way you kind of implemented that and conceptually saw that was just like this, as independent code blocks that would be executed in some way. You didn't need to think about how you would need to execute it in which order and whatnot. You just wrote the scripts for those things, the little blocks like I showed you with the grandfather clock, and you said, here, engine, execute this, and the engine would figure out how they would be sequentialized. Amazing. Again, cast yourself back, like mid to late 80s, nobody had like multiple CPUs in their computer, right? I mean, the whole idea of parallel programming was, to a large degree, still a theoretical concept. And yet here you have like the beginnings of that actually available in a game engine that actually was used to make cornerstone games. Absolutely amazing. Now I want to switch gears a little bit, and I want to talk about how an environment in a Scumm game is represented, and kind of how it's drawn to kind of give you an understanding how the engine worked under the hood. And we're going to do this by looking at the example of the Scumm bar in Maniac Mansion 1. Now, the funny thing is, an environment in a Scumm game is called a room. The data structure is called a room. Historically, that made a lot of sense, right? Maniac Mansion, you played like the majority of the game you actually spent in a room. Now, in later games, that really wasn't the case anymore, but the data structure was named, and that's just kind of what it is. Now, a room in many ways is just kind of a layered data structure. So you have a background. On top of that background, that kind of contains the static scenery, there could be a level of objects. And I'm going to come back to what objects are in just 1 second. And on top of that, there could be another layer of kind of static environment art, like mid-ground elements. On top of that, there could be yet another level of objects. And of course, this is all nice and good, but what the most important aspect of this environment, excuse me, are the so-called actors. So Guybrush and the important looking pirates. These are the player character and non-player characters that you interact with. So even though I show you this kind of layered approach or like layered schematic, like you might want to imagine this in Photoshop, internally that was not represented like that back in the day, because it would have been way too inefficient, not just from a storage perspective, but also from the rendering perspective, how you would draw it. Instead, an environment was just represented as one big contiguous image, and in addition to every pixel where you had the color information associated with the pixel, each pixel also contained information about which layer it is in. So you can see like these tables here in red are in the midground, and so is this part over here. And the reason why that is here is because Guybrush can walk behind it, so you need to be occluded by this doorway. Now, I already mentioned objects. So objects had kind of a dual purpose. Firstly, it was one way to kind of add a bit of ambient animation to an environment. So the pirates are kind of spinning, and Spiffy and the fire, all these things I mentioned are kind of object scripts. And so the way you did this back then, you kind of essentially just cycled through a bunch of sprites in your script and therefore created an animation. But the way more important aspect of an object is that it also allowed you to define gameplay logic. For example, you could associate a hitbox or like a rectangle, interaction rectangle, with one of these objects, in this case a pirate, and then as a game designer you could implement a script that defines some kind of response to player interactions. So if you say, talk to pirate, then you could implement a logic that would bring up on Monkey Island the kind of close-up shot of the pirate, and then you would have the conversation with the pirate. Or if you wanted to push the pirate probably wouldn't like that, say like, hey, what are you doing? Or if you want to combine items, same thing, right? If you want to give the grog to the pirate, then you could implement a specific custom logic with that. And of course, this kind of object interaction in combination with the conversations you have with the characters like the pirates, that are not here, this is kind of what really makes an adventure game. Now, if you needed a bit more complex animation state than just like a linear kind of sequence of sprites, you had to use actors. So Guybrush was an actor. And again, we're coming back to association to a stage play. Because the actor itself is just kind of a bucket of values, contains like the position and scale and which environment it's in. If you wanted to visually represent an actor in the game, it had to use a costume. Now, just like a real actor on a real stage play, before you step on stage, you put on a costume. And during the course of a play, you're going to wear a different costume depending on what you're doing. If you're doing the insult sword fighting, you're going to use or see different sprites than if you're digging or so on. And this is what's represented through a costume. Now, internally, a costume is just a tree structure, and it can have like one or two or one or more animations. Each animation in turn can have one or more chores, and I'm going to come back to what chores are in 1 second. And then finally, each chore can have one or two limbs, where eventually the sprites are attached to. Now, limbs is kind of, again, a weird historic term, but really internally a limb is used in a very loose way. Unless you consider your entire body to be a limb, I guess then that's fair enough. Really what they are is kind of animation layers. So if you imagine, like in this case, you have Guybrush's talk animation, you have kind of two animation layers. One that contains his entire body, kind of as one single sprite, because it's static, doesn't move. And then the part that moves is actually his head, right? He's bobbing his head a little bit, and he's opening and closing his mouth. And that's another animation layer that sits on top of the body. And this representation was done also for multiple reasons, like not only for authoring purposes, you only need to animate the parts that are changing, but also for memory purposes, so you need to store the parts that are changing. And then also, drawing performance, you only need to update the part of the screen that contains the elements that are changing. So there were many good reasons to do it like that. Now, coming back to the chores are really just kind of animation instances. So depending on which direction you're walking into, you're going to see different sprites. So a chore is kind of this representation of I'm walking to the front, I'm walking to the side, I'm walking to the back. So the kind of sprite sequence that's represented is what's considered a chore. Now, of course, this here is just a kind of logical view of a costume to kind of explain the different things that are happening in there. Physically, this is all the costume is, plus a little bit of binary data that I didn't really represent here visually, just a list of sprites. And I should point out that you'll notice that in this costume, there are only the sprites that are for like the most basic things that Guybrush can do, like walk around and pick things up and talk. You won't find any of the specialized sprites for the sword fighting and digging and so on. Like I said earlier, when these animations were played, you would actually load a different costume and then show that. And this way, you only need to have the memory loaded that you needed for the current gameplay action. Now, we need to walk around these environments, and there's still one piece missing, and that is we need to define where the player can walk, or where Guybrush can walk. And this is done through walk boxes. So walk boxes are just kind of trapezoids that are connected together. Walk boxes have also various attributes associated with them. One of the more important ones is which layer Guybrush is in when he's in that part of the room. So you can see the green elements here. Guybrush is in layer 0. In other words, he's in the background layer. And then here around the table, these walk boxes are considered to be layer 1 or midground layer. And so this is how Guybrush can walk around the table, even though this is just one contiguous image and not like layered. When Guybrush is walking in front of these pirates, he's in the midground layer, which means he's drawn on top of the table and the pirates and all that stuff. But then if he walks behind the pirates, his actor is switched to the background layer, which means that the table and the pirates are drawn on top of it, or rather, realistically speaking, what's happening is the engine will kind of figure out which pixels are occluded and only draw the pixels of Guybrush that are actually, supposedly are actually visible when he's back there. Now, you can probably tell I'm a big fan of Monkey Island. And despite of what you think of the hair of Guybrush from the special editions, I'm still consider myself incredibly lucky that I was able to work on the special editions. And I was kind of joking when I moved from Sony to California to work for LucasArts, that my one goal is to make LucasArts to make adventures again. And it was, of course, meant as a joke. And for a little bit of time, a little tiny bit of time, it almost seemed like we could pull it off. I can, again, it's amazing how many references I can bring to Ralph's talk. Being at the right place at the right time is just, sometimes that's all you need, and that's really what was the case for us as well. Now, this was the team I was hired on, and as a little side note, you probably can tell that some stereotypes are really true. I bet you can tell where the programmers are. I'm the one here with the red jacket, and if you see everyone over here standing kind of awkwardly like this, yep, that's the programmers. The rest of the team, all the artists and designers seem to have a fabulous time. So yeah. So anyway, I was actually not hired to work at Monkey Island. Instead, I was hired to work on a big AAA sci-fi game that was not supposed to be in Star Wars. But about 2 months or 3 months after I joined LucasArts, management was replaced. And with that, there was a whole bunch of layoffs and projects were canceled. And our project was one of them. And so all of a sudden, we found ourselves in a situation where some people were not fired, but they also officially had nothing to do. And so I don't know why, but instead of staying home and maybe enjoying the California sun, we decided to go to the archives at LucasArts to find the source code for Monkey Island. And in fact, we did. And this was also around 2008, which is when the kind of smartphone revolution happened, right? And being in the Bay Area meant we were kind of in the epicenter of that. And all of a sudden, we had people coming to the office with smartphones and with these amazing little screens. And we realized pretty quickly an iPhone would be a fabulous device to play some of these old adventures again. And so we dug out the code, we got it to compile, got it to run on an iPhone, and it was awesome. And right away, we realized that these games hadn't aged in a way that with the humor and the characters and design and the puzzles, all that stuff still worked very well. What didn't work very well was kind of some of the other aspects, like the sound. There was no voiceover, or visually, they were very static and very pixelated. And in my mind, when I remembered Monkey Island, especially this scene, I totally remember like this ocean was moving, and the stars were sparkling and so on. And of course, that's not how it is, and that's the kind of power of nostalgia, where you kind of have very different memories from your childhood than what actually happened in the games. And in a way, that's great, right? Because it means that these games really managed to create a world that really kind of inspired your imagination, and you kind of have all of these fond memories. But the reality sometimes looks kind of different. So what we wanted to do is we wanted to keep the games the same and all the design and dialogues and so on, but we wanted to kind of give it a new coat of paint to make it more accessible, not to necessarily players who played it back then, but to players who perhaps never played these games before. And I bet, when my daughter's old enough so I can play Monkey Island with her, I'm pretty sure that she'll probably gonna enjoy that version more initially than this, although I'm gonna make sure that she also knows about that original version. So we started to work on ways how we can add like high definition art on top of the original game. And so we did want to do things like, make the water move and add some cloud movements, and animate the stars, all so that kind of make the world appear just a little bit more lively. And the way that worked technically is by using an engine that we jokingly called the Remonkeyed engine, because it's a remastered version of Monkey Island. And I never thought like that is it's kind of funny. I gave the initial, when I first set up the project, I actually gave that engine that name, or like the kind of Windows project. And years later, I thought like nobody would ever find this name, but turns out people love going through data and to get old games, and people actually figured out like how the internal representation of the Windows handle was called. So people actually figured out that it was internally called the Remonkey engine. People are just awesome to dig out this stuff. So, like I said, one of the things that was very important for us is that we liked the original game so much, we wanted to keep the original game the way it is in terms of game design, right? So we wanted to run the original gameplay scripts with the original data against the original low-level engine layer. In other words, we wanted to run the game in a sandbox. So thanks, Raf, for inventing that name, but that's exactly what we wanted to do. And then every frame, in order to get the remastered version going, we're essentially looking at the internal state that the game is in, and then figuring out how to represent that with the remastered data. So for example, in this specific case, which environment are we in? Well, we're in a prison, okay. Well, instead of using the sprites for the original background, we're gonna go, okay, look it up. Where is the remastered? Yep, here. We find the high definition version and we draw that. And the same for the characters or the actors. Which actors are where and what animation state are they in, and instead of drawing the original version, we then find the remastered representation and draw that. And the same is true for sound, although it was a bit more complicated for the voiceover, since Monkey Island 1 wasn't really designed with voiceover in mind. We had to do a couple of tricks to make that work. Now the benefit of this architecture is that the original game still runs or still thinks that it's running on a DOS computer in 1990. In other words, it's still producing a completely valid frame buffer. And what we can do with that is we can actually blend between those two versions. And this is a feature, it's kind of funny, it's like a really minor feature, but you're just blending between two textures. But initially, we didn't really even consider this or plan it, and it's just something that's kind of happened out of a conversation with the programmers one day where we said, like, hey, wouldn't it be cool if we could just blend between those two versions? And I went back to my desk and I hacked it into the engine in about an hour or so. And it was one of those moments that was truly magical. The first time seeing this actually work. Those kind of moments you don't have that often in your career, but it just shows you sometimes, like these little sparks of creativity that just happen can really make a killer feature. So here's an example of how that looks in Monkey Island 2, this kind of blend. So you can see, overall, we tried to stay pretty close to the original artistic intent. We did have to represent some of the, especially dynamic elements like the waterfalls with particles and shade effects, just because the original version, how these were animated, are actually surprisingly difficult to do on modern hardware. Another quick example, again, you can see gameplay is pretty much the same, but now we have the ability to have shiny floors and some kind of light shaft particles and whatnot. And overall, obviously we have way more pixels. And we did try to think about what would the original artists have done if they would have had this kind of color fidelity and the additional amount of pixels. And so this is what special editions end up being. And in many ways, this really helped us later with some of the other special edition and remastered versions, because without these, we would have never made Data Tentacle Remastered and some of the other ones. Now, I do want to jump ahead a little bit in time. So from these games, Monkey Island and Data Tentacles, I'm going to go to about 1996. Full Throttle was released. And Full Throttle was already kind of a game in transition. Now, it was still kind of a traditional 2D Lucas adventure game, but it already used some of the more modern technology. Not everything was hand-drawn anymore. A fair amount of the sprites in Full Throttle were rendered through an offline rendering package, like all the bikes and whatnot. And were then integrated as sprites into the engine. And in between this and the release of Grim Fandango in 1998, there was a huge, huge change in gaming. And if you're around at the time, you may remember this was the rise of the real-time consumer 3D graphics. Where on consoles, through things like the N64 and Super Mario World, and on a PC having 3D effects or other like real-time graphics hardware that allowed you to do games like Tomb Raider. And so Grim Fandango is very much a kind of game of this transitional period. Under the hood, it's still very much an adventure game. You have to talk to other characters, you have to figure out puzzles, you have to pick up things. But it's much more modernized in many ways. It doesn't have a HUD anymore, there are no more verbs, although under the hood they still exist. And for the first time ever, the characters were drawn as real-time 3D through real-time 3D rendering. But since it was around the late 90s, the hardware was just not there and not fast enough to represent the entire world through real-time 3D graphics. So in terms of an art design decision, the backgrounds were actually modeled and rendered in a high-definition modeling package, namely Softimage, and then the characters are kind of composited into the environment, and I'm going to show you how that works. So it was a huge shift from kind of how some of the other games worked. Now, like I pointed out earlier, Grim Fandango also didn't use the Scumm engine. And the reason why that is initially they actually were considering this. The lead programmer of Grim Fandango, Brad Mogilevsky, initially kind of analyzed how much work it would be to convert 2D Scumm into, or to add a third dimension to this tech base. And he quickly figured out that it's an old engine started to be created in the mid to late 80s, a very monolithic kind of chunk of code. It was pretty difficult to just kind of add another dimension to that. So he realized, it actually probably makes way more sense to start from scratch. And this is what he did and what in the end became the Grime engine. Now, one thing that was still important for the game designers, like Tim Schafer, is that all the gameplay logic they didn't want to lose the ability to implement that in a high-level language. So these are still scripts that are not represented through C or assembly and something like that. Now, you would figure, if you want a scripting language, why not at least use the scripting aspect of Scumm? But nope, Brad actually decided to use an open source a scripting language called Lua. Now, these days, Lua is incredibly common in the games industry. In fact, I would argue that probably a couple of years ago was probably the most common scripting language. This is also because Brad gave a talk after the making of Grim Fandango, where he kind of talked about his experiences, making Grim Fandango, and I think a lot of people kind of really liked what he was saying, and then started integrating Lua into their tech base as well. So, again, innovated, although in a different way than Scumm did. But in other ways, Grime was also a much more modern approach. So rather than implementing video playback by himself as a new thing, he actually decided to integrate the video playback system made for Herbal Assault into the Grime engine as a module. Again, by the way, this library is called the Insane Video System, and it's actually pretty insane. And then a much more conventional name, the 3D renderer that was used for for Grim Fandango was originally developed for Dark Forces 2, and it's called the Droid renderer, so not quite as funny, sadly. But so you can see, the game, leveraged other libraries that were made at LucasArts, so you didn't have to write all that stuff from scratch. All right, now again, like with Monkey Island, I want to kind of give you a overview of kind of how a scene is represented and drawn. Now, since Brad and the Grim Fandango team started from scratch, they could actually rename a lot of the data structure, and one of the data structures that was renamed was a room. A room is now called a set, which makes way more sense, both in terms of a stage play, but also you had a set of cameras per environment, and if you walk around, like the game would figure out from which angle to show the environment from. Sorry, so it makes way more sense. And just looking at one of these set backgrounds, like I said in the beginning, they were created in an offline rendering package, Softimage, and were rendered in 640 by 480, 60-bit colors. And in addition to color representation, you can see over here, they also rendered out a depth buffer. Now, a depth buffer, you can kind of think about it like an image that tells the engine how far each pixel is away from the camera. And that will become, very helpful later when we want to composite in characters and in objects. Now, as a little side note, you can see the coordinate axis down here. So you can see this engine was made in the 90s because X and Y are kind of flat and Z is pointing up. And as a graphics programmer, this hurts so much. This is not where Z is supposed to point. Y is supposed to point up. But anyway, so just like with the Scumm engine, the actual gameplay, in addition to conversation, revolves around objects. And so just like with Scumm, objects have this dual purpose of having a way of animating things in the world, but also to be able to define gameplay logic. Now, in Grim Fandango, objects could be, again, sprites, or they could be animated little cards with animations on it, running through the insane video playback system. Or they could be 3D objects, like the deck of cards in the beginning of Grim Fandango. It's actually just like, you can see here, essentially like a cube with some textures on. Now, the way they were rendered is then to send them to the droid rasterizer. And for each pixel that was generated, the engine would check whether or not the pixel is further away or closer than to what's stored in the depth buffer. So you look at, okay, this pixel is here, and the associated pixel environment is down there, and so you would compare. If the pixel that we were trying to draw for this object is further away, then it's occluded and wouldn't be drawn. If it's closer than what's stored in the depth buffer, then it is drawn. And so this is how you could composite the kind of pre-baked environments with the fully 3D dynamic objects. And the same is true, the similar fashion. That's how actors and characters work. Again, they are actually called actors and costumes again. And just like in Scumm, actors are just kind of bucket of values, position, environment, blah, 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 all the typical things. And the more interesting aspect are the costumes. Now, costumes are significantly different from Scumm, though, because now the characters are made out of different mesh pieces. These days, you would probably make him out of one contiguous piece of geometry, but back then, it was actually made using rigid mesh animation. So, his upper arm is one mesh, lower arm is one mesh, and so is the wrist, and actually all the little joints for the fingers are all separate meshes. So if you wanted to animate Manny waving, you would kind of store the rotational values for the upper arm pivoted at the shoulder, doing this, and then you would store another, rotational values on the elbow for the lower arm, and so on. So this is all you need to store for the animation. It's just kind of these animation values for these kind of pivot joints. These days, of course, you would use kind of skeleton animation, where internal kind of skeleton represents the skin that's being animated. Now, after I left LucasArts in, I think, around 2010 to join Double Fine, sadly, it never really became a really stable work environment. And it kind of ended, sadly, in 2013 when LucasArts was closed entirely, which was after George Lucas sold all of his companies to Disney. And Disney quickly realized having a game studio in San Francisco that actually doesn't produce many very successful games is probably not a smart move, because it's incredibly expensive to live in San Francisco and to have a company there. But thankfully, this gave us the opportunity at Double Fine to give kind of a similar treatment to Grim Fandango that we had previously given to some of the other LucasArts games. So we started to work at the remastered version. Now, when we started working there, we kind of looked at the original game, and we kind of quickly realized the environments are actually held up pretty well. Since they were created, modeled, and rendered in Softimage as a high definition rendering and modeling package, they look pretty good. They had lots of shadows and lighting in there, which you can do when you just bake things out into images. But what really didn't look very well were the characters and the objects. You can see Manny is really low resolution. You can see stair-stepping. The textures are super grainy. The lighting is very flat, and the shadows are just completely blocky mess. And all of that, Manny just doesn't look like he belongs in this environment. He just looks like a sticker was put on top of it. So we kind of realized that we should really focus on trying to make sure that the characters integrate more into the world, and this is what eventually became the remastered version. So you can already see the difference between those two versions. So here's another quick example, and you can see his face texture is obviously much higher resolution. You can actually make things out, and the textures are not so grainy, and the shadows are projecting correctly on the ground and floor. So overall, Manny just looks like he belongs really in this environment compared to the original representation. Now, all of this was done through the Grim remastering technology base, and we actually started out pretty similarly to how we did handle the Scumm games. We did keep huge parts of the gameplay completely untouched, so the scripts stayed mostly the same, the data stayed entirely the same, and a huge part of the original C code base we also left unchanged. We did have to make a fair amount of changes to the scripts, mostly because Grim Fandango was pretty buggy when it originally shipped. So we wanted to take the opportunity we had with the remastered version to fix some of these bugs, to make it a much more streamlined experience. And also, in Grim Fandango, a lot of the kind of more lower level gameplay or logic, like for example player controls, was implemented in Lua. And so in order to modernize that a little bit, we had to go in and change some of that code. But visually speaking and through the sound, it still very much works like we did with the Scumm games. So every frame, we kind of look at the internal state and then figure out what kind of version of the remastered data we should show. We did actually end up using the exact same meshes for all the characters because they work very well as part of the kind of overall art design and the kind of stylistic decisions that were made when Grim Fandango was originally made. So we felt like we didn't need to add more polygons to that. But of course, we did want to, as I said, change the texture. So every time the game is trying to draw any kind of object, we have a little callback that says, okay, I want to draw this texture. Okay, instead of using the original version, just show the remastered version. And again, the same, this similar fashion audio was done. So here's a kind of a moving version. You can see the side by side. So you can see all the shadows being correctly projected on the environment. And I hope you agree, Manny looks a bit better in the remaster version. Having more pixels makes a huge difference. And the way the artists approach this kind of this remastering process, essentially by looking at, okay, how did the original artist set up lighting in these environments? You can kind of figure out from the shadows being projected from some of the objects that there had to be a light source, on this side. So we were trying to figure out, where these original light sources were, so that we can create some for the characters that could be used for Manny and some of the other characters. Another quick example from the beginning of the game. Now again, mid to late 90s, hardware was just not fast enough, and it was just not possible to calculate shadows correctly. So when Manny starts out, he's actually in a completely shadowed area, but yet he's completely brightly lit. And we were thankfully able to fix that for the remastered version and to add kind of a little extra bit of film noir to that too by adding these kind of blind shadows. Now, we did run a little bit of a snag there, though, is because we just couldn't find the original 3D assets for the environments anywhere. They were just not in the archives. But we really needed a kind of 3D representation for the artists so that they could figure out where to put light sources. And so given that we didn't have the original 3D models, we ended up using the different camera angles that are used in the game and then back projecting that into 3D space. So using information about where the camera is and the depth buffer information, we can figure out where the pixel would be in 3D space, and then we would color that with the color of the actual pixel, and then create a quad in Maya that represents this pixel. And so this looks a bit like kind of a Kinect representations of this kind of depth buffer, and it's you would definitely not be able to use this in a game like this, but it was enough for the artist to kind of make out where's the desk. You can see this here. It's a table. I don't know why it's stuttering, but there's a table here, the desk, the computer, the window, so you can kind of figure out where things are supposed to be. And this is how the artist could tell where to put on light sources. So you can see all these wireframe objects are different types of light sources, point lights and spotlights. And then you can see how we did the extra shadow casting objects for the windows. We actually allowed the artist to create some extra geometry that was then considered when the shadows were calculated. So unfortunately, I'm kind of running out of time. There's a lot more to talk about, and I could probably talk about adventure games, LucasArts adventure games, like half the day. But sadly, I had to pick kind of my points that I wanted to talk about. And so I hope you enjoyed the talk, and I hope you learned something about these old games, and I hope you kind of now would consider the technology that was used to make these games also as kind of one of the aspects that comes to mind when you think about them. And yeah, thank you very much for listening to me, and I'm happy to answer some questions if there's time. All right.
What's your favorite character?
What's my favorite character? I think pretty sure Guybrush. Just because I have so many fun memories playing the game. In fact, Monkey Island was my first game I had on my first PC ever. And it was also before I could really properly speak English. And so trying to figure out how Monkey Island works was pretty funny. And there are just so many excellent aspects. I think this kind of anti-hero of Guybrush is just fascinating. There's so many, the more I work on these games, the more I realize how much depth there is to that. Like the fact that the reason that he's called Guybrush is because the characters were created in a paint program that had the extension brush, and it was just the guy.brush was the file that was used. They didn't know how to name him, so that's how the name Guybrush came into place. And so it's just, I don't know, I just really like him. I think there's another question over here.
Of the games you talked about today, which one did you find the most interesting to work on, and why?
I probably still have to pick Monkey Island just because I never thought that would happen ever, really. How often do you get a chance to work on something that you enjoyed as a kid later on when you're grown up and you actually work in the industry? But each one of these games had a different challenge. So probably why everything was completely new and for me, and I kind of learned so much about these games with Monkey Island. There was also a lot of learning experience with Grim Fandango, and just kind of see the progression of how technology matured and how games were approached at LucasArts during that time was very, very interesting to see. But yeah, again, Monkey Island is also my favorite game, so it's kind of hard to compete with that. Oh, there's one more.
So you have a long background in making games and remaking games, and what approach do you take when looking at these old archives? Because I accept you have to learn a lot of new things, and some of it is rather obscure.
Yeah.
What do you do?
That is actually a very good question. Yeah, so I gave a talk at GDC a couple of years ago, talking a bit more about that. I think it's available for free as well. Anyway, so it's interesting because the archiving process, the way it worked back then is they essentially took the computers that each one of the team members had and created an image of that. So, when you get the data back from the archiving team, you just get a snapshot of the life of a developer back then. So, you find Doom on those computers. So people played Doom in the office back then. Well, that's interesting. But you also find, obviously, all of these files. And, given when these games were made, that was before Perforce existed and before Git existed and other stuff. So the way kind of data management worked back then is just you had the files in the computer. If you wanted to share it with another developer, you just put on a network drive and they pulled it from there. Which means that if you want to figure out what is the actual real data to use, it's kind of tricky because you have all these different versions done at different times, stored on different developers' computers. And very often we actually had to write a lot of technology around that, trying to figure out which one of these is the true version that was used in the game. And in many ways, the way we approached it is by saying, okay, the ground truth version is the one that was shipped, on an actual disk. So we took the pack files that came as Monkey Island, and we actually extracted out all of the data that's used in the actual game. And then using this kind of binary representation, we then say, okay, is it possible to associate the original source files with that? In many ways, that worked better or worse for some of the games. In many ways, often what we did is we actually let the artists create art based on these original internal representations that was shipped as the game. So we created Photoshop files from the data that was in the pack files, and so on. So there's a lot of that and a lot of, just digging through documents. Some of the things we could do for the later versions, like Data Tentacle, having this kind of concept gallery. People from the team could go up to George Lucas's ranch and look at the physical archives. So you can actually scan some of the original concept paintings. So there's a lot of kind of that, just digging through lots and lots of data. Not always super interesting because you just have like a million versions of everything. But it is kind of fascinating to kind of just see a snapshot out of the life of a developer. Yeah. And in terms of approach, it's just you can't really formalize it too much. You just have to deal with what you find. Okay. All right. Well, thank you very much. And also, if you have more questions, please, do just stop me anywhere in the halls or whatnot, or at the party tonight. I'm happy to talk about it much more. Yeah, thank you. All right.